In your previous lectures, we have studied, first we have studied your structure of compiler, then we have studied the phases of compiler with outputs, then we studied parsing, types of parsing, and the first parser I have taught you is your top down parsing, okay, and in that I have studied, we have explained recursive parsing. Recursive parsing is what? Top down parsing with backtracking. In top down parsing with backtracking, there were two disadvantages. One was your left recursion and another one was your backtracking. Then we have studied the methods of elimination of left recursion, then we have studied elimination of backtracking, which is also called as left factoring. Today we are going to start with a predictive parser, that is a parser which accepts the grammar which is free from left recursion as well as backtracking. So, as per the concepts that we have studied, so how many types of parser are there? Basically, one is your top down parsing, second one is your bottom up parsing. In top down parsing, first what we get is your recursive parsing. What is recursive parsing? The parser or the grammar which contains left recursion and backtracking. Okay, when we eliminate this, eliminate the left recursion and eliminate the backtracking, the parser that we get is called as recursive descent parser. So, when we construct the next parser, that means what input we will take? We will take the recursive descent parser. That means the parser accepts the grammar. It accepts the grammar which is free from your left recursion as well as backtracking. Okay. So, the parser that accepts the recursive descent parsing which is free from left recursion as well as backtracking is named as predictive parser. It is named as your predictive parser. So, today I am going to explain you in this video what is a predictive parser, what is the constituent of a predictive parser, how a grammar is being processed in a predictive parser and how we will reach at an output. Okay. These steps I will explain you in this particular video. Okay. For this what we have to do? First we have to understand what are the constituents of a predictive parser. Okay. Now see, what are the constituents? The constituents are, now this is a block diagram. Okay. Whenever the question comes for a predictive parser, first what we have to do? We have to make the block diagram. This is your predictive parser program. This is your predictive parser program. And to process is what we need? We need an input string, and where the string will be stored? The string will be stored in a input buffer. Okay. Let's say this is a string A plus B. This is for an example, and dollar will be there at the end of the input in the input buffer, and this is named as your input buffer. Okay. Now, this will be connected because the predictive parser program will take the input that is stored in the input buffer. Okay. Then, element will be stored where? When we implement your predictive parser, the input is stored or processed using a stack. Okay. Stack, and the string or the grammar will be entered or stored in the stack. Okay. Then, we have to construct predictive parser. We are constructing means lastly we have to construct a parsing table. We have to construct a parsing table. Okay. So, what are these? These are the main constituent of a predictive parser. It uses a stack. Okay. This is your stack. It uses a stack that which consists the grammar symbol, and also uses an input buffer which contains the input string. And what this predictive parser program will give us? It will give us the corresponding output. So, this is the main constituent of the predictive parser. Okay. Then, how to recognize the stack symbol? It will enter a end marker. So, what is the end marker over here? The end marker over here is, end marker is your dollar. Okay, this symbol is used as your end marker, and also in the input buffer it will enter an end marker. Here I have already included over here. If in the input buffer is storing a string A plus B, then at the end what it will store? It will store a end marker, that is a dollar sign. Okay. Now we will see the working of a predictive parser. That means what? We have to take a grammar, a context free grammar, and we will see how a given string is being processed using your predictive parser program. Okay. Now, let us see. Let us take an example. Okay. Let the input string be. We will take an input string. Let the input string is id plus id star id. Okay. Then grammar will be given to you. Okay. Let us say the grammar given to us is E tends to T E dash tends to plus T E dash or epsilon, T tends to F T dash, okay, T dash tends to star F T dash or epsilon, F tends to bracketed E or ID. Okay. Now, look at this grammar. I have already taught you elimination of left recursion. Now, see, if you remember in my previous lectures, you can refer to my previous videos. There I have taught you elimination of left recursion. Okay. After eliminating the left recursion from the grammar which was given to us E tends to E plus T or T, we have got this grammar. So, now what I told you, when you will take a predictive parser, the grammar has to be free from left recursion as well as backtracking. Now, see, this is the grammar which is free from your left recursion and backtracking. Now, if a question comes, if a grammar is given, let us say this grammar is given, okay, and this string is given to construct a predictive parser, then the very first step that you have to do is to eliminate left recursion. Without eliminating left recursion, if you are doing, then it is wrong. Okay. Now, we will see what to do. Then, how to construct, how to parse the string. First, the predictive parser will contain stack will be there, where we need to store the grammar. Okay. Then, input string will be there. Input string means the string that we have taken for example. Okay. Then grammar. Okay. Now let us start. What I told you, the first element that will be stored in the stack will be the starting symbol. What is the starting symbol in the question given? E. So what will store first? E. Okay. Then what the stack will contain? An end marker. So E, then a end marker, that is a dollar. Okay. Input string means ID. See the input string given over here, ID plus ID star ID. So ID plus ID star ID. At the end again it will enter a end marker. Okay. Now here we have the starting symbol as E. Now what we have to do? We have to take a production which starts with E. Now look at the question. For E we have only one production, that is E tends to TE dash. So what we will write over here? E tends to TE dash. Okay. Now in place of E, what we will write? In place of E we will write what we have taken, E tends to TE dash. So here I will write TE dash. Now E is replaced by TE dash, then I will put a dollar. Okay. Now ID plus ID star ID and dollar. Now what is the production for T? Production for T is your FT dash. Okay. So now I will write T tends to FT dash. Now replace T by FT dash, E dash will remain, then dollar. ID plus ID star ID and dollar. Now for F. Now for F we have two productions. One is your bracketed E, one is your ID. Now what you have to do? You have to check now what is on the top of the first input string, that is your ID. Now what we do, parsing we are doing means we have to parse the entire input string and reach at the end marker. Okay. Now here we need to get the same symbol or same terminal symbol as in the stack top, so that when the stack top and the first input string matches, we will pop it out. Okay. Now despite of taking F tends to bracketed E, what we will take? We will take F tends to ID. Okay. Then I will take F tends to ID. Now replace it ID, T dash, E dash and dollar. Okay. Then here is ID plus ID star ID dollar. Now here at this point of time no grammar will be accepted, because when the stack top and the first string matches, we will perform a pop operation, because stack has basically two operations. One is your push operation, another one is your pop operation. So when it matches, this ID and this ID will be popped out. So what will remain? T dash E dash dollar. Here ID is popped, so plus ID star ID and dollar. Okay. Next what we need to pop out? We need to pop out plus. Now look at the productions given to you. In this productions what is given? E dash tends to plus TE dash. So if I keep this T dash, it is not going to serve my purpose. So what I need to do is I have to eliminate this T dash. Now check for the productions of T dash. T dash is having two productions. T dash tends to star FT dash or epsilon. So better is what? To eliminate T dash, I will take T dash tends to epsilon. Okay. T dash tends to epsilon. So here what will remain? E dash dollar plus ID star ID and dollar. Now for E dash what I will take? E dash tends to plus TE dash. Now replace plus TE dash dollar plus ID star ID and dollar. What will do? Again this plus matches, so it will pop. Okay. So when it will pop, what will remain over here? TE dash dollar ID star ID dollar. Now what I need? ID. Here on the stack top what I am having? T. For T only one production is there. So take T tends to FT dash. So FT dash E dash and dollar. ID star ID and dollar. As I have already done this, the same way we will do F tends to ID. So ID T dash E dash dollar ID star ID dollar. Now both the string matches, so it will pop. So what will remain? T dash E dash dollar star ID dollar. When we take, one thing you have to remember, when we take this, what we have to look? We have to look at two things. What is in the stack top and what is in the top of the string. Because when these two will match, then only we will perform a pop operation. So according to that, we have to take the production. Now for T dash, I am having star FT dash and epsilon. I need a star. So no need to eliminate T dash. What I will take? I will take this. T dash tends to star FT dash. So what I will write over here? Star FT dash E dash and dollar. Okay. Now star ID dollar. Star star matches, so no operation. So F T dash E dash dollar ID and dollar. Okay. Now what you are having? ID, and here I am having F, and we have a production F tends to ID. So what I will take? F tends to ID. ID T dash E dash dollar. ID dollar. So no operation. So ID will be popped out. T dash E dash dollar, and ID popped, so remain dollar. Now see, what is our task? We are given with a string. We are given with a string. We are given with a set of grammars. We have to see whether the predictive parser is parsing this string completely or not, successfully or not. For that what we need? For that we need, on the stack we should get the dollar only, and in the string also dollar should be there. Now here I got dollar means what? The entire string is complete now. No element of the string or no portion of the string is there to be processed further. But I need a dollar over here as well. Now how to do that? T dash, I am having a production, T dash tends to epsilon. So now what I will do? I will take T dash tends to epsilon. So what remain over here? E dash dollar, again dollar, again for E dash I have E dash tends to epsilon. Again what I will get? Dollar, dollar, here I will write accepted. If I am not reaching at the end marker over here, if I am not able to process all the input string given to me, then I can say that the string and the given grammar are not successfully parsing the string using your predictive parser. Okay. This is how, using your stack, we process a given string and a given set of grammar which is free from your left recursion and backtracking, both. Okay. Both it has to be free from. Okay. Then only we can say that the string is successfully processed. Okay. Then comes, what is the figure C? Block diagram I have explained you over here. What is the block diagram says? Now see, input buffer, I have told you string was stored, ID plus ID star ID. Stack, starting symbol was there and dollar was there. Predictive parser program, and predictive parser program is, we use the push and pop operation for the stack and generated the output. Now what is the last thing remained over here? Parsing table. Now what are the rules to construct your parsing table? Now see, what are the rules to construct your parsing table? Procedure to construct a predictive parser. Okay. These steps we have to follow to construct a predictive parser table. Okay. First step, what I have told you previously, the grammar has to be free from your left recursion and backtracking. So first step is your elimination of left recursion. Second step is your elimination of backtracking, or we can say perform left factoring. Okay, perform left factoring. Then third is construct the parse table. The next step is to construct the parse table. Construct the parse table using two functions. Okay, what are the functions? We have to calculate first. It is a function, so we are writing in capital and it will be followed by a pair of parentheses. Whenever we will write first, we have to write a pair of parentheses. Second one is your follow. These two functions we need to calculate because these two steps we have already studied. Elimination of left recursion, elimination of backtracking, or perform left factoring. Third step to construct the parse table is we have to study about two functions, that is calculation of your first and your follow. Okay. Then what we will do? We will do check the validity of the input string by using the parse table, which we will construct after calculating your first and follow. Okay. So, in this video today, what we studied? I am just brushing up what we studied. We studied predictive parser, okay, then constituents of predictive parser, okay. Third, how it will parse an input string using a stack. Okay, these three things we have studied today, and in the next video we will be studying construction of constructing or calculating, whatever, both are same, calculating first and follow. Okay, then we will construct the parse table. Hopefully you will find this video beneficial to you. You will understand the concept. Okay. For further updates, you can refer to my next video, and for that you can please like, share and subscribe to my lectures, so that any updates I will give to this, you will be able to find out the updates of it. Then we will go to the next topic, that is your first and follow, in your next video. For further updates, please subscribe to the video. That's all for this lecture.